welcome to the session. This is Pi System and the greater technology landscape. This is the first session in the Pi intro track. So if you're new to Pi world or if you're new to the Pi system, this is a great place to hang out for the afternoon. Like I said, the first session here, we're going to talk about how the Pi system fits into the greater technology landscape. After that, we're going to go into a crash course in the Pi system, where you'll learn more about how to speak Pi lingo and how to get the most out of Pi world. The third session is going to be about asset monitoring, so specifically CBM, or condition-based monitoring. It's one of my favorite topics. And then the fourth and final track, or the fourth and final session, will be about analytics, so how to use the Pi system to get going with analytics. So for this session, I have it broken into three sections. The first thing I want to talk about is what's the problem? What's the problem that the Pi system is trying to help solve? After that, I want to talk about the data landscape. People use the term data a lot nowadays, and I want to give you a framework for how to think about that. And then the very last thing is I want to go through a very quick introduction to the Pi system architecture, and I'll show you what a typical deployment looks like for a single site and for an enterprise. All right, so let's just jump into it. What is the problem? What's the problem the Pi system is trying to help solve? Now, what it comes down to is connecting people with operations data, so data from operational data sources. And anyone who's worked for an enterprise or worked in manufacturing knows that there's a lot of different tools and software and databases that go into helping us do our jobs. You might have a LIMS system for your lab data, a historian, an ERP system, and over time you might add another SQL server. There's that Excel spreadsheet that's really valuable. It's almost like its own database gets passed between team to team. And there end up being all these different connections between these different parts of the system. And over time, it becomes increasingly tangled. And I lovingly refer to this as the spaghetti bowl architecture. And you can see why. It looks like a mess of noodles from all these different connections from one source to another. And there's some good that comes from even a deployment that looks like this. Even with a deployment this complicated, oftentimes if you're a motivated user, you're familiar with the architecture, you know how to find the data you need, and there's a tool that's helping you do your job more efficiently, and that's great. But over time, this just isn't the most sustainable solution, because inevitably, you'll have to upgrade one part of the system, and there'll be so many hooks and interconnections between the other parts of the system that it can be very complex and time-consuming and expensive to do that upgrade. And then even more importantly, for a new user, someone new to the company or new to a new team, they often don't know where to go to find the data they need, or they don't even realize what data is at their fingertips or what's available to them. But I know when I talk about something like this, when I hear people talk about solving a problem like this, it still feels very ambiguous. It feels a little hard to relate to sometimes. And I think the best way to make it real is to use an example. So let's make it real, and I want to give you an example from my past job. So I've been working with the Pi system for about 10 years now, half of that time with OSIsoft. But before that, I worked for a chemical manufacturer down in Houston, and I worked as a process engineer. And every day, there were three databases that I would look at. They were really critical to me. They helped me understand, are we in spec, and are we hitting rates, and did anything happen last night? That's kind of what I wanted to know every day when I came to work. So we had a quality control lab, and we would catch samples from the plant. We would take it to the lab. They had really sophisticated analytical equipment there, and they would help us determine if our product was in spec. And that went to a LIMS system. So LIMS stands for Lab Information Management System. We also had a control system. It was a Bailey Infa90 control system. And this was hooked up to a historian. And I would look at this every day to see, are we hitting our target rates? Did we hit the tonnage we were supposed to hit last night? And then the last database I would look at was a Microsoft Access database. And this was something the operators would use at the end of each shift. They would type in, how did things go that shift? And more importantly, there were quantitative inputs as well. So if there was a sample that they caught, and they wanted to run a very simple test, we would run it in our wet lab, which was a lab that was out in the plant. It was for very simple measurements, things that didn't merit, or things that weren't so complicated that it needed to go to the quality control lab. So something like a density or conductivity. And they would enter that information into this Access database. But it wasn't just me that had to look at this information. It was me and a team of about 12 people. There was always 12 people every shift, on Monday through Friday, who had to look at this information to see how are things running in the plant. So the way we did this was we had what we called our morning stand-up meeting. So the morning meeting, it was every morning at 7 a.m., and we called it a stand-up meeting because you had to be physically standing up. The idea was if you sit down, if it was a sit-down meeting, you get comfortable, you start chatting, it takes a long time. But if it's a stand-up meeting, everyone's standing up, they're at attention, and the goal is to get through this information quickly. And since we had to go through the same things every day, we ended up saying, hey, we should create a dashboard to help us do this more effectively. So we had a dry erase board, and we drew a grid up there that looks like this. The first column, kind of like the y-axis, that's just the parts of the plant. So one part we called 14th Street, one part we called 15th Street. And then across the top, that first row, or the x-axis, that was just the days of the week and the shifts. So the diagonal lines are separating the day shift from the night shift. And the idea was at the end of each shift, the operators that were working, they could just run some calculations, figure out what the average rates were, make sure that there was no quality issues, and then they would take a green marker if everything was good and write down what happened. And if there was a problem, they would write that with a red marker. And I don't know if you can tell looking at this dashboard, but it didn't really work for us. In fact, it was a huge failure. And the reasons it didn't work was this was a very manual process. It was very error-prone. So oftentimes we'd look at this in the morning and say, I don't know if I believe that number. Could we re-query the historian? Could we recheck the quality control lab and make sure that data is accurate? It was very time-consuming for the operators to do this. And because of that, at the end of the shift, that time is precious for them. They hated doing it. The operators just did not like doing this. But lucky for me, this was an opportune time. Oh, before I go on, I want to point out a couple things on here. So if you look at 15th Street on Tuesday, where there's supposed to be a number, here we just have some question marks. For the other parts of the plant down lower, we just have data missing entirely. And then I think my favorite part here was for 14th Street on Sunday, instead of a number, we just have a smiley face and a frowny face. I don't know what that means. So like I said, this just didn't work for us. But this was an opportune time. Lucky for me, I'd been at the plant for about 6 months, and the automation engineers, along with plant management, said, hey, we're upgrading part of our system. We're moving to this thing called the Pi system. I said, OK, that sounds exciting. I don't know what that means, but all right. They said, well, we're going to go to this thing called the Houston Regional Seminar, and we'll learn a little bit more about what that means. And the Houston Regional Seminar, it's kind of like a mini version of the event we're all at right now. It's like a mini Pi World just for a smaller audience. And I was sitting in the audience just like you all are right now. Then I went back to work, and I found there was a ton of videos on YouTube where I could teach myself all the basics of how the Pi system works. And that's when it hit me that I could create a real-time dashboard. Instead of this dry erase board, I was convinced I could create something just like that, but fully automated. So I went back to work, and I created this thing. When we upgraded to the Pi system, we took those 3 different databases, pulled them all into Pi, and I found out there was a tool called Pi Data Link that made it really easy to pull all that data in Pi into a spreadsheet. So I'm a chemical engineer by training. I feel comfortable using a spreadsheet. That's a tool I like to use. So when I found out I could get this data into Excel, it was super easy to set up the same thing. It's just a table. And I have it set up with conditional formatting. So if a value is above a limit, it turns green. And if it's below a limit, it turns red. Super, super simple. But even just looking at this visually, when you all were looking at that dry erase board, it's very confusing. You couldn't tell me what's going on. But someone who's brand new to the team, they can look at this dashboard and they can say, hey, I see what's going on. I see Tuesday, the only problem was on 15th Street. We were a little bit below our target rate. It's very easy. And the thing I like about this dashboard is it's fully automatic. Once it's set up, it updates super easily. Anyone can update it. Even though it's 5 days of data, it updates incredibly fast. And best of all, it's accurate. So everyone trusts it. And this totally transformed the way our morning meetings went. So even though we called it a stand-up meeting, sometimes the meetings would take us 40 minutes because we'd have to re-query information and we'd have to talk about what to do. And it took us a long time for everyone to get on the same page. This was 12 people from operations, people from maintenance, I&E technicians, so instrumentation and electrics, and even plant management. But having this electronic dashboard, this really, really simple tool, helped us get from a 40-minute meeting to meetings as fast as 40 seconds. I remember the day we had that first meeting that was under a minute. We came in, it was a Tuesday, we looked at the dashboard and said, well, before we talk about the dashboard, we have to have our safety topic for the day, because that's really how we start all of our morning meetings. We talked about ladder safety. Always have a partner, make sure someone's holding the ladder for you. And we said, hey, looks like everything on the dashboard's green. We're good to go. That's the end of the morning meeting. And I think that was the day that it kind of hit all of us that this was a really powerful tool. That's when it hit us that the power of the Pi system was bigger than we realized. And this was kind of just the first domino to fall. This was kind of that light bulb moment for us where we said, man, this wasn't that hard to set up, and this really changes the way that all of us start our days. And it was from this point forward that we said, man, this dashboard was so easy, what else could we do? We thought about our air compliance reporting, the way we reported on our NOx and our SOx. It was also a very manual, very time-intensive project. And we realized we could do the same thing. We could automate this with Pi. When it came to working with the logistics team, kind of similar to what Pat mentioned this morning, the people who worked in logistics, they would call the control room, or they would call me, especially on Fridays, to say, hey, what are the tank levels? We want to know, do we need to order anything new going into the weekend? We want to make sure we don't run out of material. And I said, man, I could just create a simple dashboard for them, and then they can see the tank levels themselves. Super easy. So if we go back to the problem here, the problem the Pi system is trying to address is it's all about connecting people with the operational data they need to do their job. And this is often a really hard, complex task. But that's where the Pi system comes in. The goal of the Pi system is to be that data infrastructure that connects your people with the operational data they need. So I know when I first heard someone say this, that the Pi system's an infrastructure, I said, man, that's kind of a weird word. Like, why are we calling it an infrastructure? Why would we use that word? And again, I love the way Pat explains this. When Pat talks about an infrastructure, he says, if you notice the infrastructure's there, it means there's a problem. Because when it's working perfectly, it should basically be invisible. And another example of an infrastructure would be something like water. If you think about what it takes to just get water out of a sink, even here in the hotel, you just walk to it, you turn it on, and the water comes out. You don't need to think about this water came from the Sierra Mountains, it had to melt and go to the Hutch Hutchie Reservoir, it had to go through a pumping station to get to the Bay Area, there's probably a booster pump to make sure the pressure's high enough in the hotel, and all the piping behind that. You don't have to think about any of that. It just works, it's invisible. And that's the goal of the Pi system as well. To the end user, they don't need to think about where's this data coming from? What are the connections between all these databases? All they need to know is if I have a question, I need to answer it, and it requires operational data, I just go to the Pi system, and the data's there. It's as easy as turning on the faucet. OK, so moving to the second section here, I want to talk about data, the data landscape. So like I mentioned earlier, people use the word data a lot. It's kind of a pet peeve of mine when people just say we use data or we're data-driven, because I always think to myself, well, what does that mean? What type of data are you using? So this is a really simple framework for how to think about some of the most common types of data you're likely to run into if you work in operations. So I'm just going to run through these real quick. The first type, unstructured data, it's a little bit more nebulous to think about, but unstructured just means data that does not have a defined structure. So think about things like photos and videos or a log file dumped out by a program or machine. A good example of this would be something like Twitter. Like anytime someone tweets something, it could either be words, it could be a URL, it could be a photo, an image, an emoji. The structure of the tweet is not defined, so the back-end system for that is an unstructured database. Secondly is geospatial. This one's pretty easy to wrap your head around, just putting things on a map. So tracking the location of something, GPS coordinates, things like that, that's geospatial data. This third one, relational. This is things that you store in a tabular format. You could also think about it as things that are more transactional. But a good example of this would be like the specs of a pump. If you have a pump, you might want to know who manufactured it, what was the model number, what size impeller is in it right now, what was the date it was installed. Information that doesn't typically change really quickly over time that you could store in something like an Excel spreadsheet. So a relational database is kind of like an Excel spreadsheet on steroids. And a really common example of a relational database is something like SQL. This last data type is time series data. So time series data usually originates from a sensor or a measurement. So a good example of this would be something like the temperatures, pressures, levels, and flow rates that are all hooked up to a control system. They typically change very quickly over time and are often sampled as quickly as once a second or even faster. So the reason I think it's helpful to think about what are the different data types that are out there is because if you just think about the different roles or the different departments of people across an enterprise, everyone's using data, but the way they use data and the types of data they're using may be very different. So again, if I just think about the company I used to work for, when I worked at that plant in Houston, I was a process engineer, and I was also responsible for some of the utilities. So the data I was looking at was things like, what's going on in the boiler room right now? What's happening to the pressure of the boiler? Are any alarms going off? I'm looking at time series data that's changing very quickly. The logistics team, on the other hand, they're thinking about things in a much more transactional way. So they want to know, did that truck come and unload the raw materials? Or, oh, we have some finished product. How are we going to make sure this gets to the correct customer? We were selling products to refineries. So did this final product get to the refinery it needs to get to? They were looking at some time series data too, but usually it was more of a summary or something they looked at more infrequently. And then people at the corporate office, they were looking at different data types altogether. So they're thinking about what's happening with the global refining industry, what's happening to the price of crude oil, what's happening to the margins for our customers. They're looking at news articles, they're looking at quarterly reports from the units and the different plants that we work with. So they're looking at a combination of unstructured data, relational data, as well as time series data. But the point is, everyone uses data, but not all data is the same. And the last reason I really want to talk about this is because I think it's helpful to to kind of understand, how does a pi system work with these different data types? So when it comes to time series data and relational data, this is where we built database technology from the ground up to really work with these two types of data. Especially when it comes to time series data, this is what the Pi Data Archive was built to do. There's a lot of people who think the Pi Data Archive is the world's best time series database. And if you think about it, lots of control systems have thousands and thousands of instruments hooked up that are being updated once per second or even more frequently. So it's very important to have a database technology that's built to handle this volume of data, both for storing it, for storing tens of thousands of events per second, but also for querying this data. So when you want to run a monthly report like my quarterly NOx report, if it's 3 months of data, and it's even 10 sensors that are sampled once a day over 3 months, that's a ton of data. But luckily, the Pi system is so performant when it comes to this type of data that that report can be run in a matter of seconds. I want to explain a little bit more about why we have this relational component as well, so I'll come back to that. But when it comes to geospatial and unstructured data, you typically don't store maps or photos in the Pi system, but there are lots of use cases where it makes sense to combine operational data with a map or with a set of unstructured data. And the way we do that is with our technology that we call our Pi integrators. So the Pi integrators are just one of the technologies we have that make it easy to get data out of the Pi system and combine it with a different data set or a different tool that's not made by OSIsoft. So an example of this would be, if you think about even DCP this morning, they talked about how they have over 2,000 compressors scattered across over 9 states. If they wanted to show that information on a map, we have a partner named Esri, and we have an integrator for Esri that can take data out of the Pi system and display it on a map produced by Esri. Same thing when it comes to unstructured data. But I think the real takeaway here is just remember, when it comes to time series data, the Pi system is really, really amazing at storing that. But when it comes to getting it somewhere else, OSIsoft has a really open policy to data ownership. I remember talking to a customer about this, and they said, one thing I love about the Pi system is that you guys are like the Switzerland of data ownership. You know, even if the data needs to get somewhere, or I need to get the data somewhere, and it's not one of your tools, you make it easy for me to do that. So we have developer tools, we have APIs, as well as these Pi integrators that make it really easy to do that. But going back to this relational component, you know, I've had people ask, you know, why didn't OSIsoft just make a time series database? If that's what you guys are so good at, why do you bother at all with relational data? And the reason for that is because you need more than just raw time series data. And I want to give you an example to kind of make the point here. So if you guys were all on the team with me back at the plant, and we were all part of that stand-up morning meeting, and I said, hey, everyone, welcome to the meeting. Just want to let you know we got some new data in here. The new sensor value is 37. Is that good or is that bad? That's okay. Right, it's hard to say. It's hard to really say because what is 37? You'd have to ask some questions to get some more context, right? You'd want to know, what is this? Is this a temperature? Is this a batch ID? You'd want to know, what are the units? 37 degrees Celsius is a cold day. 37 degrees Celsius would be a really hot day. 37 degrees Fahrenheit would be pretty cold outside. You'd want to know, where's this coming from? Is this coming from a pump? Is this coming from a tank, a transformer? And you'd want to know, where's it located? And this is all the information that we can store in a relational database. And we use a tool called Pi Asset Framework to make this happen. And the takeaway here is that when it comes to this raw time series data, you really need this greater context to turn it into consumable information. And I think this is becoming increasingly important as there's more and more people trying to look at the operational data that we all work with. It used to be, if you're a process engineer, maybe you just know the tag name. So if I said, oh, 37, that goes back to TI 138303, you'd be like, oh, OK, I know what pump that's coming from. I know what that means. But now if you have a data scientist who's at corporate, who's at a totally different state, totally different building, they really need this additional context to turn this into consumable information for them. So I think it's really important. So this is an example of a Pi Vision display. This is one of our visualization tools. It runs in any web browser. And I think it's a good example of how you can combine all these different sources of information into a single display. So if I highlight this part right here, this is just that raw time series data along with a prediction. So you're comparing both your actual versus your predicted. Right here in this About section, we have some contextual information. And I forgot to mention, this is a dashboard for monitoring the health of a wind turbine. So right here, we're saying, OK, what's the serial number of the turbine? Who manufactured it? What's it rated for? At the top, we have some calculations that are also performed in the Pi system, so giving us a summary of how efficiently is the turbine running, how often has it been available. But the nice thing is, to the end user, they don't have to know where are all these different data points coming from. To the end user, all they need to know is if I want to check the health of my wind turbine, I have this one dashboard. I can go here, and I have everything I need. It's a one-stop shop. And if you're wondering how hard is it to build a tool like this, it's very, very simple. If you're comfortable using a tool like PowerPoint, where you can drag and drop some shapes around, you can make a dashboard just like this. OK, so moving to the last section here, I want to talk a little bit about architecture. If you go to any of the other tracks and you hear us talk about our technology, the people who work at OSIsoft, we like to think about things in this kind of data flow architecture pattern. So the first layer here is our data collection tools. So this is what we call our Pi connectors and Pi interfaces. And this is really the first point of contact with the Pi system and kind of the outside data source. Now, this is a set of software that runs on a Windows operating system. We do have a select group of connectivity tools that run on Linux as well. But most of them run on a Windows server. And the whole purpose of a connector or an interface is kind of to be a translator. So we say the Pi system is going to be this infrastructure. It's going to pull in data from all of your operational data sources. And part of the requirement to do something like that is you need to be able to speak to all the data sources, meaning all the control systems, all the PLCs, all the different places. And since these are often made by different vendors, you need technology that can speak all these different languages. So since OSIsoft was founded, we've developed over 450 different interfaces and connectors to connecting to all the most common operational data sources, and even some of the ones that are not so common. The last thing I'll say about this is you typically want to install this server very close to the data source. The more you can minimize the amount of network hops or potential points of failure between the interface connector and that data source, the better off you are. So the second layer here is the Pi server. And this is where we have our two database technologies. So the Pi Data Archive, which specializes in storing that time series data. And then Pi Asset Framework, which is that relational component for building out all that additional contextual information. These components also run on a Windows server. And you could install both of these on the same Windows server. And we see people who do that, especially for something like a testing environment. But if you're going to go for a full production environment, we typically recommend that you install each of these on their own server so they're not competing for resources. Now, the third layer here, this is Deliver. This is where we have our client tools. So I've already mentioned two of these today. The first one for the dashboard at our stand-up morning meeting, that was using Pi Data Link. So Pi Data Link gets data from the Pi system and pulls it into Excel. And the second tool, the one we just looked at for the wind turbine dashboard, that was using Pi Vision. So Pi Vision is our browser-based tool, meaning it can run on anything with a web browser. So a computer, a tablet, a phone, anything like that. So you might be wondering, how long does it take to set something like this up? So I used to work in field service. I helped dozens of customers set up an installation just like this. And typically, we could set something like this up in 3 to 5 days. It's really, really easy to get it going because there's no custom code to make this happen. All these components are just off-the-shelf software. You install it, you do some configuration, and you can get it working. So I just want to show you a couple examples of a basic architecture. This is what a basic architecture looks like for a single site. So if I think about the site I used to work at in Houston, just that one site, that one Houston site, this is what the deployment kind of looks like. You typically have your control systems that are in that process control network, that very protected part of the network. It's usually separated from the internet by several firewalls. Then you have the demilitarized zone, and that's where we see customers often install their interfaces and connectors. It's a really good place for it to live. From the DMZ, the interface is going to pass the data along to the Pi server, and the Pi server is typically installed in the business network. And then the business network, that's the same part of the network that most of the users are connected to. So that's where the visualization tools are installed as well. So I think it's obvious from the architecture, but I just want to point out one thing that's really cool about the way the Pi system works and the way it's chopped up into these different servers is it makes it very easy to traverse this type of network topology, to get from that very sensitive control network and safely and securely share that data with a much larger group of users. Now, if we go beyond a single site and we want to set up an enterprise deployment, this is typically what we see customers do. You have a Pi server at each site. So I had the site in Houston. We had a sister plant that was in Amsterdam. They had a Pi server as well. But then we had our corporate headquarters in Baton Rouge, Louisiana. So the folks at corporate, they had their own Pi server, and then they could pull data from both the Amsterdam plant and the Houston plant and roll it all up to a single Pi server. And then from there, it's the same visualization tools to expose this data to all the business users. So we've covered a lot of ground already. We talked about the Pi system and the problem it solves, and how it can be a data infrastructure for your sensor-based data. We talked about the data landscape. I gave you a framework for how to think about the different types of data that are out there. And then lastly, we talked about what are some of the typical Pi system architectures that we see out in the field. So this is my contact information. Feel free to jot it down and reach out to me anytime. Happy to talk about any of this. It looks like we still have maybe just a minute. I think maybe time for one question. So I think we have a mic in the back. If anyone has a question, feel free to just throw your hand up and we'll bring the mic over to you. I think we've got one over here.
Thank you, Jeremy. The question I have is related to the SQL backend. You talked about an enterprise environment. Is it recommended to have a single SQL backend for the main Pi server, or individual SQL databases or instances at each one of the different locations?
Yeah, that's a good question. So I think we've seen deployments. I've seen deployments where people kind of go with both options. But I think the typical recommendation, in general, the recommendation with our software is, we like our software to have its own resources whenever possible. So it depends on if you're going to kind of try to join the Pi system backend with an existing SQL server, I guess the consideration would be you really want to make sure that that thing's not being overutilized. So in general, the recommendation is we want to give it its own SQL server just so there's no competition for resources. All right, I think we're pretty much out of time. I just want to leave you with one final thought. It's not hard for me to remember what it was like when I was first learning about the Pi system and I was at that regional seminar. So I'm really excited for the people that are in this room. If you're new to the Pi system and new to Pi world, I think you're in the best possible place to see the awesome things that people are doing with the software. And I think you'll find some great inspiration for those projects that can hopefully be that first domino to fall and lead to a great chain reaction of projects back at your business. So thank you so much and enjoy the rest of the conference.